So we have a question, let's say. The question is basically given as y equals to 3 plus 4x minus x squared. This is actually a question of this paper. Paper 1 variant 1 of, and the question number is actually, this is actually question 10 from the October-November session. So 2010 October-November, okay, October-November session. And the question number is question number 10 from the paper, variant 1. I mean, variant 1, paper 1, variant 1. So the question goes something like this. The equation of the curve is given as y equals to 3 plus 4x plus minus, 3 plus 4x minus x squared, okay? Now, they're asking, or in the first question, let's show that the equation of the normal to the curve at the point 3x is 2y equals 6 plus 9. Show equation of normal to or normal to the curve at point 3, 6 is 2y equals to x plus 9. Okay, they're asking us to do that. So how are we supposed to do that? They're saying that if such is a, let's say, equation, somewhere it lies over here, let's say. Like, why am I drawing this sort of curve? Because this is a quadratic equation. It could be seen here. Okay, any sort of quadratic equation looks like this, but it should be somewhere upside down, since it has a negative x squared. So that means it will be somewhere somewhat like this. So rearranging this equation gives minus x squared plus 4x plus 3. Okay, so it looks something like this, or it should look something like that. Now, talking about the equation, if we simply know the x and y coordinates, isn't it, of certain equation, and we, in order to know the equation, in order to have the equation y equals to, we have to know what y equals to mx plus c. That's the equation of the straight line, and they're asking us to show the equation of the normal. That means somewhere here, let's say at the point 3, 6, that means this is the coordinate which they're mentioning. At that point, they're asking us what should be the equation to the normal to that point. Now, what does normal mean? Before normal, we have to understand what does tangent means. They didn't mention the term tangent here, but we have to know what does the term tangent means. Tangent means, let's say, if we draw a certain straight line at that point to the curve, the gradient of that curve at that point is equivalent to the tangent of the straight line passing through the point. Okay, if that makes sense. That means we should draw a tangent, a straight line. Remember, I mentioned earlier in the first class of the demonstration, in order to find the gradient of this point, we take a ruler and find two position, then find the values, like the difference in the value of y and difference in the value of x. We find y2 minus y1 divided by x2 minus x1 in order to get what? The gradient of the curve at that specific point. So that straight line we drew with the ruler is actually the tangent to the curve at that point. Okay, so that's what tangent means. Now normal means, if that's the tangent, if we would have, let's say, hold a separate ruler at 90 degrees to that tangent, at 90 degree to that tangent or to that ruler, that straight line is known as the normal. This is the normal. Okay, this was the tangent to the curve. This is the normal to the curve. Okay, this is known as the line of normal, or normal to the curve, or normal line. Like, that's what it means. Okay, they can mention it in different form. Now, if that's the normal, there is a formula we usually learn in our O levels, but still I'll mention it here, that if a straight line, like if two straight lines crosses each other and they have a 90-degree difference in between them, okay, or simple word, if one is tangent and another is normal, then the product of their gradient, that means if the gradient of this tangent is, let's say, m1 and the gradient of this normal is m2, the product of their gradient should give us a value of -1. Okay, that means m1 is actually -1 by m2. Similarly, m2 is -1 by m1. Just simply rearranging the equation. See, if we subject m1, m2 goes to the denominator of the right side, isn't it? That's what I wrote here. Similarly, if I just subject m2, m1 goes to the denominator of the right side, isn't it? So I just like simply subjected it. Now using this method or using these formulas and concepts, it is very easy to find the solution to this curve, okay? Or solution to this like equation. Solution to this question. They're asking us to show that the normal has the equation to the curve at the point this, which is this one. Forget about this equation at first. Let's find the equation of the normal. Before that, we need what? The gradient of the normal. We already know like a coordinate of the normal, isn't it? Because the normal actually passes through that point. In order to find the normal to that point, obviously that normal should pass through that point, isn't it? Otherwise, how are we supposed to find the normal at that specific point? So that means the normal actually passes through that point. That means we have a coordinate at the point. So from here, this equation, we have the y and x value. We need the m value. What do we say that? We need the gradient value. In order to find the gradient to the normal, what do we need? Use this concept. Let's say m2 is our normal. M2 is our normal. We don't know the value of m2, but is there any way to find the other values? Are you like we have -1 here, but can we find the m1 value? M1 is what? Tangent to the curve. Tangent to the curve means what? Whatever the gradient of the tangent is at a specific point, the gradient of the curve is also same. Now, if we don't have any information about tangent, which in this case we actually don't have any information about tangent, but tangent depends on what? The curve. Does we have or do we have any, I'm sorry for the bad English, but do we have any sort of information regarding the curve? Yes, obviously we have. We have an equation. And of that equation, we have specific coordinates as well. So it's very easy for us to find the gradient. So simply just dy by dx, which is actually gradient itself, the equation for gradient we are finding, this should give us what? Gradient of dy by dx of this equation should give us -2 times x, which is the differentiation of this -x square, plus differentiation of this 4x is what? 4. And differentiation of 3 is what? 0. So we don't need to write it here. So simply -2x plus 4 is our equation of the gradient. Now we are able to find the gradient at the specific point. So simply just placing the x value in this equation gives us -2 times 3 plus 6. That should give us a value of -3 to the 6. So that means we have a value of, did I, oh yeah, I like took the wrong thing. I'm sorry. This should be actually not 6, this should be 4. This is actually 4 here. -2 times 3 plus 4 here. Yeah. So now it makes sense. So -3 to the 6 plus 4. So -6 plus 4 gives us what? -2. So that's the gradient of this tangent. Okay. The tangent mentioned here, the gradient of the tangent at the specific point, this one. The tangent to the curve at the specific point is given. That means m1 is here, -2. So now using this formula, we're able to find m2. Simply just -1 by m1, we can find the value of m2, which is -1 over -2. Remember to give the -1 of the formula and also to mention the sign of the value. Since the sign of this gradient is what? Minus. So we have to give both the signs. So minus times minus is plus. So the gradient of m2 is 1/2 or half. Now, if we try to find or place the gradient value here, y equals to m is 1 over 2, x is normal x plus c. Placing the value of x and y, we can find the value of c in this case. Now, what does that mean? C is actually, if we like extend this axis over here, and if we extend the normal line, which is the red line, if we extend it, we can see it intersects somewhere in that y-axis, isn't it? That intersection of y-axis is known as C. We need to find the C here. So how can you find it? Just simply place the value of x and y. Now, which value of x and y? They have provided us with certain coordinate. Simply place that value because that coordinate actually lies on this equation. That's what they mentioned. So, like as they have said, normal to the curve at the point here. Since they mentioned it here, that means the normal like the normal line actually passes through that coordinate, isn't it? So placing that coordinate, we can find the value of C, which in this case should be 6 equals to 3 by 2 plus C. That should give us C equals to simply 6 minus 3 by 2 equals to 6 to the 12, 12 minus 3, which is 9 over 2. Finally, we have an equation y equals to half x plus 9 by 2. Taking 2, doing LCM gives us x plus 9 by 2. Finally, we can bring the 2 to the left side. That means multiplying 2 with by 2, y equals to x plus 9. And finally, we have actually our equation here, which actually is same as this equation. So that means it is shown. Okay, it's proof that the equation is actually of the normal is actually this. Moving on to our next question. The second part of this question. Let's clear the board. They have said, or they have asked that given that the normal meets the coordinate axis at point A and B, find the coordinates of the midpoint of A and B. Okay, so they are saying that the normal just we found, it meets the coordinate axis. So let's again draw the curve. Let's say this was our curve. They said this normal to certain point 3x, the normal to this, like this is the normal equation, normal line. They say like this meets the coordinate axis. Now, what does the coordinate axis means? Coordinate axis means, remember, like what do we mean by coordinate? Coordinate means x and y, isn't it? Coordinate means x and y. And coordinate axis means that x and y, the axis of x and the axis of y. Because since we represent the coordinates as what? X and y. That means coordinate axis means the actual axis and like all the axes. Okay, that's the coordinate axis means. So this is one axis. That is one axis. Like axis is the singular form and axis is simply the plural form. That means both the axes they are mentioning. That means if it's extend the straight line, it should meet somewhere in the x-axis and it should meet somewhere in the y-axis. I'm sorry for the bending. Let's try to draw it a bit more clearly. Let's say like this, okay? So somewhat like that. Now they're asking, or they're saying that the meet at certain point, which are let's say considered as A and B, okay? We are supposed to find the coordinate of the midpoint of A and B. Now we have already found the value B. Now, how I say that? Because remember, in your just previous question, like in question number 1, we found the y-intercept, and this was actually the y-intercept. B is actually the y-intercept, the value of C. And we found C was what? 9 over 2. And the equation was actually 2y equals to x plus 9. Or we can simply write it as y equals to half x plus 9 by 2, isn't it? If that's the case, in all the axes, what is the single thing we know? In this axis, like in the y-axis, do we know the value of x? And the value, when is c equals to 9 by 2? Can you mention? Or can you try to observe? What is c? C is actually y, isn't it? The value of y. but the value of y at which point? The value of y at the y-axis. In y-axis, do you know what is the value of x? You can guess, and actually you do know. If we consider here, see, if this value 1, this is 2, like the x value 1, x value 2, x value 3, 4, 5, like it increases, isn't it? But at which value of x does the y-axis lie? Can you say? At the 0 value of x, isn't it? At the 0th position of x, this is the y-axis, isn't it? That means what? The value of x at y-axis is what? 0. The value of x is 0 at y-axis. That means at any value of y, this is where any value of y lies, which is on the y-axis, the x value is 0. Okay, that's what it means. And x value is 0. When x value is 0, the y value is 9/2. That's one thing. Similarly, when they're asking us to find the value of a, or like simply this is the x-axis, isn't it? Sorry for the inconvenience, but as I was mentioning, like the other device actually got disconnected from where I usually like tend to record. So trying to continue from wherever it got paused. I was mentioning that this was what? The y-intercept, and this was the x-intercept. Now, talking about this intersection, like extending this straight line to the y-axis and towards the x-axis, we already got the y-intercept, isn't it? And y-intercept means what? The y-axis, like the value of y in the y-axis is in this situation is 9/2. But do we know what is the value of x? Yes, obviously we know, because we have like this y-axis lies on which value of x or which position of x. If these are the position of x, x is 1, 2, 3, 4, then at which value of x does the y-axis lies? Obviously at 0, isn't it? Like it is observable, and it is the situation that at the value of like x equals to 0, the y-axis lies. So the straight line, when we extend it, at which value of y is the x equals to 0? So that means when x equals to 0, the y value in that for the straight line is over here. Similarly, when we extend the straight line towards the x-axis, at x-axis, what is the information we know? We know that x-axis lie on the y values, like the 0 value of y, isn't it? In the x-axis, like the x-axis in the 0th value of the y. So that means when y equals to 0, this x-axis, I mean, at y equals to 0, the x-axis lies. So we are supposed to find at which position of the straight line, which is this normal, when y equals to 0, what is the value of x? They are asking us to find that. So simply just placing the y value 0 here, we should be able to get the x value. So subjecting x, simply just crossing out, or cross multiplication. Doing cross multiplication means the 2 goes above and 1 becomes to the bottom part. So 9/2 times 2 by 1. So simply 2 and 2 cancels out, and simply we have -9. That means it is somewhere in the negative axis, isn't it? Yes, that's what they're mentioning. And that's what it's supposed to be. Okay, if that's the case, so it be, so that means we got 2 points, which is the value of b is, let's say, in this case 0 and 9/2, because 0 was the x value, and at the x value we have got the y value as 9/2, and at the x-axis our x value is -9 and the y is, we know, it's 0. So simply they have asked us to find the value of the, like the coordinate of the mid point. So this is the coordinate of the midpoint. Okay, so how to find that? Simply just we have to use the formula, which is x2 plus x1 over 2 y2 plus y1 over 2. Okay, simply add them and divide it by 2. So similar, like simply just we will be doing here what? We have two x values, so simply 0 plus minus 9 divided by 2, and y is 9 over 2 plus 0 divided by 2. We are getting a value of minus 9 by 2, and we're getting a value over here 9 by 4. So that should be our value, our equation, like the coordinate of the midpoint. Okay, that was the second point, second question. Now the third question is find the coordinates of the point at which the normal meets the curve again. Okay, so they are saying that the normal meets the curve again somewhere. Now it is also observable from the equation, like from the diagram here. If we extend the curve, let's say towards the bottom, okay, and if you extend this straight line, see, it crosses somewhere again. Over here at this point, they meets again. So how do we solve them then? If they cross each other at a certain position, that means what? Their coordinates are the same. So what does that mean? That means their y position and like both the y position should be same. Similarly, both the x positions should be same, isn't it? If that's the case, then we can actually use this method that like both have the equation, like we have the equation for both the curves. The straight line equation is y equals to y equals to 1 over 2x plus 9 by 2. That's the equation for the straight line, I mean the normal. And the curves equation is we have minus x square plus 4x plus 3. So if this is equation 1 and this is equation 2, that means if this is the y value, like if we represent a subject makes the like make y the subject in equation 1, which is the straight line, and y in this case is the subject, like we have subjected y already, and the expression of the y is this. That means what? This y value and that y value should be equal, isn't it? I mean the straight line values, like y's value and the curve's y value should be same. That means what? We can actually say equation 1 equals to equation 2, isn't it? That should be the case where they should meet each other. So if that's the case, we can then like solve them simultaneously by writing half, like just taking the LCM. Okay, just write it down at first. Half x by 9 by 2 equals to minus x square plus 4x plus 3. Simply, we are getting, we can just do the LCM here. So x plus 9 over 2 equals to minus x square plus 4x plus 3, making this part common, I mean the subject, so x plus 9, and cross multiplying 2 to the right side. So 2 gets multiplied with all of them, isn't it? So multiply with 2. No, 2 individually gets multiplied with all of them. So we have x plus 9 equals to minus 2x square plus 8x plus 6. Simply bringing all towards one side. So let's bring the right hand side towards the left side. So it becomes 2x square, positive 2x square. Then we have, if we have already plus x, we bring the 8x to the left side. That means it becomes what? Minus 8x, isn't it? Minus 8x, because we are changing sides. So changing sides also changes the signs. And we have positive 9 here already, and moving x to the left hand side becomes what? Minus 6. That is equals to 0. So simplifying them, 2x square minus 7x plus 3. Okay. Now if we just do some simultaneous equation, we should be able to solve them out, and we should be able to get the value. So the simultaneous should be 2x square. Just simply try to see that doing what we get this minus 7x. So in this case, 2 times 3 is what? 6. So from 6, this is actually one value less. So we can do this actually, minus 6x minus x, because negative 6 times negative 1 becomes what? Gives positive 6, and we have 2 times 3 as 6. So also negative 6x minus x gives us what? Negative 7x plus 3 equals to 0. So simply this is our simultaneous part, x minus 3 minus 1, x minus 3 equals to 0. So we are left with taking common x minus 3, and we have 2x minus 1 equals to 0. Finally, we have x minus 3 equals to 0, 2x minus 1 equals to 0. Therefore, x equals to 3 and x equals to 1 by 2. Now, which one of them are the correct answer? One of the coordinates should be known to us, because in question number 1 they have already mentioned x equals to 3 already. So that means the other value is our final answer. So x equals to 1 by 2 is our answer to the x coordinate. Finally, if we place this half in one of the equation, either in the curve or in the straight line, we should be able to get the answer. Let's place that in the straight line equation or the normal equation. So y equals to half times half plus 9 by 2. So this should give us actually 1 by 4 plus 9 by 2 equals to, doing LCM gives us 1 plus 2 9 is 18 divided by 4. So that should give us 19 over 4. So finally, we have a coordinate which is half and 19 by 4. So that should be our coordinate to the straight line. I mean, the coordinate at which both the normal and the curve miss with each other. Okay. So that's one of the question paper question. I would be providing some more examples, some more question to be done in the homework uh, in the description box. So do check the description box. Inshallah, I'll be providing all the required maths to be done as the homework. Okay. So take care. Allah Hafiz. Assalamu alaikum.